today's lesson is called Derivative Applications, which is also the title of this unit. And there are no note cards. It's going to be a short lesson. Basically what we're doing in today's lesson is I'm going to give you word problems, and in a lot of them you're not even going to have anything you have to solve for. You just have to explain what something would mean in terms of the word problem. So basically we're not learning anything particularly new today. We're just applying what we've learned to situations. So the problems that I'm going to do with you are from your actual homework assignment. I'm going to do one on the front and one on the back, and then you should work on the rest of them in pairs or groups, small groups, to see what you can do with these. Put your heads together and use your good problem solving skills. So, first one, problem number 1, is the temperature T in degrees Fahrenheit of a frozen pizza placed in a hot oven is given by T equals F of T, where the little t is the time in minutes since the pizza was put into the oven. So, part A here says, what is the sign of F prime of T and why? Okay, so F prime of T is the derivative of the temperature equation, which is going to describe the rate of change of the temperature equation. So, how is the temperature changing when it is placed into this hot oven? Well, the temperature is going to increase as it's in the hot oven, so the sign would be positive because the temperature is increasing. So that's kind of referring back to what we learned in our graphical analysis unit. A derivative is positive. We have an increasing function. Okay, B. Explain the meaning of the statement F prime of 20 equals 2, and it says be sure to include units. So F prime of 20 equals 2. So 20 is in the place of the little t. So that means, and t is time in minutes, so 20 minutes after the pizza went into the oven, the rate of change of the temperature is 2. To what? 2 degrees Fahrenheit per minute, based on the units given in the problem. So the rate of change of the temperature of the pizza is 2 degrees Fahrenheit per minute, 20 minutes after it went into the oven. Okay, so here in this problem we didn't do any calculating at all. All we did was read this problem and interpret what these things mean about the problem. So there's a lot of those like that, especially on the front page. Then on the back, we're going to do number 7. Lee Purr attaches himself to a strong bungee cord and jumps off a bridge. At the time t equals 3 seconds, the cord first becomes taut. From that time on, Lee's distance, y, in feet, from the river below the bridge is given by the equation y equals 90 minus 80 times the sine of the quantity 1.2 times the quantity t minus 3. And it kind of makes sense that we would use a sine function to describe how far away he is from the river, because he's going to be yo-yoing up and down. The y distance from the river will be increasing and decreasing. So, find the value of y of 15. By the way, on this worksheet, I want you to use your calculator for all derivatives and every one of these problems. We're going to use calculator on the whole thing. So, y of 15, all that means is plug 15 in for t, and you do that in your calculator. So you can just type in 90 minus 80 times the sine of, in parentheses, 1.2 times, in parentheses, 15 minus 3, close parentheses, hit enter. Make sure that you are in radian mode, always in calculus, unless told otherwise. So y of 15 comes out equal to 12.747. And we're supposed to explain the meaning. So Lee is 12.747 feet from the river. 15, time is in seconds, after this situation begins when the chord first becomes taught. No, because 3 seconds is when the chord first becomes taught, so it should be 15 seconds after he jumps. Okay. And B. Oops. I don't like that C. Find the value of y prime of 15 and explain its meaning. So to do this, you're going to go into y equals and type your equation in there. And you're going to hit graph. You're going to want to make sure that your window is set up so that it includes x equals 15. So it needs to go at least to an x max of 15. You could go all the way out to 20 if you wanted to. But it has to be included on the screen. Then you're going to hit second and the trace button for the calculate menu. And then you're going to hit number 6 for dy dx. And then you're just going to type in 15. And the screen will automatically come up with an x equals 15 at the bottom. And then you hit enter. And then on the screen it's going to tell you that the derivative is equal to 24. We'll round to 3 decimal places, 942, which is the answer. And then we have to interpret that answer in terms of the problem. So this is the rate of change, which the rate of change for this particular problem would be in feet per second. So it would be 24.942 feet per second is the rate of change, is his rate of change. That's how fast he's traveling 15 seconds after he jumps. So Lee is traveling 24.942 feet per second after he jumps. And that's it. So, work on these with your peers and see what you can do with this. This is our last lesson of this unit. So, next is the review and the test. Good luck!